For decades, humanity believed it had finally deciphered the universe. Modern cosmology built an explanation so solid, so accepted, and seemingly so precise that it came to be treated almost as absolute truth. This explanation was named the Lambda CDM model, a framework capable of describing the expansion of the cosmos, the formation of galaxies, and the very evolution of the universe since the Big Bang. For a long time, it seemed that all the pieces finally fell into place. But perhaps we were looking at an incomplete picture. Perhaps the real universe is much stranger than our physics has been able to imagine so far. And at this very moment, a telescope floating about 1.5 million kilometers from Earth may be exposing deep flaws in the foundations of modern cosmology. We're not talking about minor adjustments to calculations. We're talking about something much bigger. The James Webb Space Telescope has begun observing phenomena that simply shouldn't exist. Looking further and further back in time to the earliest chapters of cosmic history, Webb found impossible structures that completely defy the timeline predicted by the Big Bang. Gigantic, bright, and seemingly mature galaxies emerging too early, as if the universe had evolved too quickly. Now, some Nobel Prize winners are quietly admitting that the primordial universe looks very different from what we imagine. And this has led certain scientists to ask the most radical question of all: do we correctly understand the origin of the universe? To understand why these discoveries are shaking so many researchers, we first need to understand the basis of modern cosmology. For decades, the Lambda CDM model has dominated virtually all of our understanding of the cosmos. According to this theory, the universe is primarily controlled by two invisible components: cold, dark matter, and dark energy. Together, these forces shape the expansion of the universe and the formation of galaxies over time. According to this model, the primordial universe should have been a relatively simple environment: dark, silent, and still largely unstructured. Matter would only have been beginning to slowly clump together after the Big Bang. This period became known as the Cosmic Dark Ages, an extremely ancient phase in which stars and galaxies should not yet have emerged. But then the James Webb Telescope came into operation. And Webb doesn't just look at distant places, it looks directly into the past. Each point of light captured by it traveled billions of years to reach its sensors, coming from a time before the birth of the sun itself. And when Webb began to analyze these ancient regions that should reveal a still young and chaotic universe, it found something unexpected. Instead of emptiness, it found complexity. It found massive structures. It found extremely bright objects that already seemed to have developed too early. They were not small, primitive clouds of gas scattered throughout the cosmos, as the models predicted. There were thousands of objects that were too bright, too massive, and too dense. Astronomers analyzed the data and repeated the same phrase several times. This doesn't make sense. Webb is observing complex structures where complexity should be mathematically impossible. It is finding objects that are too mature for a universe that is only 13,800,000,000 years old. And this is not a data error. Independent teams around the world are observing the exact same phenomenon. The operating system of the cosmos seems to have crashed. And here's why this is a nightmare for physicists. The Lambda CDM model establishes an extremely rigid timeline for the growth of the universe. According to it, the first galaxies should grow slowly, accumulating matter over enormous periods of time and gradually forming stars, piece by piece. Based on everything we know about gravity and dark matter, there simply wouldn't be enough time, or enough matter, for giant galaxies to appear just a few 100 million years after the Big Bang. It's like walking into a nursery and finding a fully grown adult wearing diapers. The timeline simply collapses. Even so, Webb is observing galaxies so large and dense that, mathematically, they would require more matter than the universe could provide at that early stage. The numbers don't add up. The physics don't add up. A study published in the Astrophysical Journal identified 87 candidate objects that may have existed only between 200 and 400 million years after the Big Bang. And, to put that into perspective, confirming even a small fraction of these objects would be a huge problem for cosmology. One of the researchers, Haojing Yan, summarized the situation directly. If these objects are real, our understanding of the formation of the first galaxies is fundamentally wrong. We're not just rewriting a chapter of the science textbooks. We're realizing that perhaps the entire book was written in the wrong language. And as if impossible galaxies weren't disturbing enough, the details get even stranger. In the current universe, galaxies are relatively inefficient. When a galaxy forms, Only about 10% of the available gas is transformed into stars. The rest remains as gas, floating through space and feeding future generations of stars. It's a slow and gradual process. But the data from Webb suggests something radically different about these ancient objects. Some of them seem to have converted 100% of their matter into stars. Think about that. No gas left, no reserves, no fuel for future growth. A level of efficiency that simply shouldn't be possible according to any known law of physics. This has led scientists to ask uncomfortable questions. Are these objects really galaxies? Or are we observing a completely new type of cosmic structure, something that doesn't fit into any existing category? If they are galaxies, the implications are enormous. This would mean that the Big Bang model, as we understand it today, is incomplete, or worse. Perhaps the universe has evolved faster than our theories allow. Perhaps gravity behaves differently on cosmic scales. Or perhaps, just perhaps, the visible universe is only a small part of a much larger reality. To understand what might be happening, we need to step back and rethink the very behavior of the universe. In 1929, Edwin Hubble made a discovery that changed everything. He realized that galaxies are not scattered randomly. They are moving away from each other. Space itself is expanding. And here's the strangest part. This expansion has no center. No matter where you are in the universe, everything seems to be moving away from you. Every observer sees themselves as the center of the expansion. But the universe isn't just expanding. This expansion is accelerating. The farther away a galaxy is, the faster it moves away from us. Eventually, there is a limit to how far galaxies recede at the speed of light. This limit is called the Hubble sphere. Beyond the Hubble sphere, galaxies are moving away faster than light itself. This seems impossible, but none of Einstein's laws are being broken. It's not the galaxies that are traveling through space faster than the speed of light. It's space itself that is expanding and carrying everything along. As the universe continues to expand, the Hubble sphere grows over time. This means that light from some galaxies, which were previously moving away faster than light, can still reach Earth. Their photons are literally climbing a kind of cosmic escalator that keeps getting bigger as they move forward. But there is a definite limit, a final frontier. This boundary defines the observable universe, a gigantic bubble about 92 billion light-years in diameter. Everything beyond it is permanently hidden. The most distant galaxy ever identified, known as Jade's GSZ 14-0, emerged when the universe was only about 290 million years old. But there's an even more impressive detail. What this galaxy has become today will never be observable by us. It has already crossed the observable cosmic horizon. Whatever its current form, it is forever beyond our reach. This happens because the observable universe does not represent the entire universe. It is only the small region of the cosmos that we can see. And if the universe really is infinite, something that more and more evidence suggests, then the Big Bang did not happen at an isolated point in space. It occurred simultaneously everywhere. This means that there are entire regions of the cosmos completely inaccessible to us, areas so distant that we will never be able to see them or interact with them. But perhaps the James Webb is beginning to reveal indirect clues about what exists beyond our observable horizon. And to understand why these seemingly impossible galaxies are shaking modern cosmology, we need to correct one of the most misguided interpretations of the Big Bang itself. Many people imagine the Big Bang as a common explosion, happening at a specific point and launching matter outwards in all directions. But this image is wrong. If the universe is infinite and everything indicates that this is possible, then it was born infinite. The Big Bang was not an explosion occurring within space. It was space itself expanding everywhere at the same time. Matter did not arise in a central region and then spread throughout the void. It appeared simultaneously throughout the cosmos. This is precisely what helps explain the cosmic microwave background radiation, the famous CMB, that faint glow detected in all directions of the sky. We are seeing the remnant light of this primordial event reaching us from all sides. But this is where the James Webb Space Telescope begins to challenge traditional models. If the early universe was a kind of warm and relatively uniform ocean of matter and energy, then gravity would need a long time to form the first complex structures. But Webb is finding gigantic structures at a time when only primordial chaos should have existed. It's like opening the oven moments after putting in the batter and discovering a fully baked and decorated cake. The impression is that part of the structure was already in place even before the baking process began. And this isn't just being discussed in internet forums or through speculative theories. The unease has reached the highest levels of the scientific community. Some of the most respected physicists on the planet, including Nobel Prize winners, have begun to quietly admit something surprising. By analyzing data collected by different teams around the world, many have realized that the primordial universe may have been radically different from what we had imagined until now. For decades, suggesting that the Big Bang might not have been the absolute beginning of everything was practically professional suicide. It was considered cutting-edge pseudoscience. But Webb's data is so disturbing that scientists are now considering ideas that were once seen as taboo. And they are considering a much more radical possibility. What if the universe didn't begin the way we believe? What if those distant objects aren't even primitive galaxies? What if they belong to something completely different? This is where we enter one of the most impressive theories that has been gaining traction: cyclical universes. The idea is simple and terrifying. What if our Big Bang wasn't a beginning, but a rebound? What if our universe is just one among infinite universes that expand, collapse, or disappear repeatedly in eternal cycles? Some physicists are looking at these impossibly bright objects found by Webb and wondering if they could be remnants of structures that existed before the Big Bang itself. Imagine a previous universe coming to an end, leaving behind cosmic seeds, supermassive black holes, or extremely dense regions that survived the transition. When our Big Bang occurred, these seeds would have instantly accelerated the formation of galaxies. This would explain why we see gigantic, fully formed cosmic monsters only 200 million years after the beginning of our timeline. They didn't start from scratch. They had an early advantage. They are ghosts of a past reality. And if that doesn't seem absurd enough already, there's another possibility being taken seriously. A Nobel Prize-winning physicist even publicly suggested that Webb may have found evidence pointing to something beyond our own universe. Remember, the observable universe is just our local bubble. If these ancient objects are too large and evolve too quickly for the laws of physics within our bubble, perhaps they are being influenced by something that exists outside of it. Perhaps the universe we perceive is only a small part of a much larger reality. Just as a fish in an aquarium can see shadows moving beyond the glass, perhaps Webb is detecting gravitational influences from structures that exist beyond our cosmic horizon. This suggests that what we call the universe may be just a small region within an infinite and timeless fabric. If we set aside the multiverse for a moment and look only at pure physics, the situation becomes even worse for the standard model of cosmology. The problem is not just when these galaxies formed, but how. In the universe as we understand it today, governed by conventional thermodynamics, star formation is a messy process, inefficient. In typical galaxies like the Milky Way, there is a lot of gas available, but only about 10% of that material actually collapses to form stars. The rest is expelled by radiation or remains scattered as fuel for future stellar generations. But Webb is observing these ancient monsters and seeing something that completely defies logic. The data suggests that some of these primitive objects converted 100% of their matter into stars. This is the nightmare of efficiency. Imagine putting a liter of fuel in a car and being able to drive millions of kilometers without any loss of energy. It shouldn't be possible. There are no leftovers in these galaxies, no gas left, no fuel for future growth. If these data are correct, it means that the fundamental laws describing how matter collapses under the action of gravity, laws we believe to be universal, may not apply to the primordial universe. And this brings us to the second possibility that physicists are beginning to whisper about. If the timeline is impossible and efficiency is also impossible, then perhaps the very force responsible for everything is wrong. The lambda CDM model relies on dark matter as a kind of gravitational glue that slowly binds galaxies together over time. But Webb is observing events that are too fast for this glue to work. So scientists are forced to ask an uncomfortable question. What if gravity itself behaves differently on cosmic scales? We assume that gravity is constant. We assume that it functions today in exactly the same way it did 13 billion years ago. But what if that's wrong? What if gravity in the primordial universe was more intense or operated under different rules, drastically accelerating the formation of cosmic structures? It sounds like science fiction. But when you alter the intensity of gravity in the equations, those impossibly massive galaxies suddenly become possible. The problem? You need to abandon the idea that Einstein's general relativity completely describes the universe. You have to admit that our cosmic operating system is in need of a massive update, and this leads to a deeply disturbing conclusion. The Big Bang model, as we understand it today, is incomplete, or worse. We spent decades building a house on a foundation that we believe to be as solid as rock. But Webb is showing that maybe it's made of sand. If the physics don't add up and the numbers don't add up, then we're not just failing to understand a planet or a star. We are failing to understand a fundamental mechanism of reality itself. Some researchers are already stating outright that our understanding of the formation of the first galaxies is fundamentally wrong. We are observing a universe that has evolved much faster than our theories allow. And this forces us to confront an uncomfortable fact. The observable universe, that bubble we can see, is not the entire universe. We are trying to deduce the rules of an infinite ocean by analyzing only a glass of water. And to understand the magnitude of this moment, we need to remember that we've been through something similar before. Before 1929, the greatest scientists on Earth believed that the universe was static and unchanging. Then Edwin Hubble proved that it was expanding, and a single discovery destroyed the physics of the time and rewrote all the scientific textbooks. Now history seems to be repeating itself. The idea of an expanding universe seemed absurd until it was proven. Today, the idea that our physics might be wrong, or that structures predating the Big Bang itself exist, also seems extreme. But data doesn't care about our feelings, or our Nobel Prizes. Right now, we don't have definitive answers. We only have data. And Webb's data is practically screaming that the universe hasn't finished surprising us yet. We are facing another 1929 moment. So, where is all this leading us? If the James Webb Telescope has already been able to trigger a crisis in modern cosmology just by beginning to observe the primordial universe, what will happen when it delves even deeper into those first moments of existence? At this moment, the telescope is being used at the maximum limit of its capacity. Astronomers are pointing their instruments directly at the period known as the Cosmic Dark Ages, that extremely ancient phase right after the Big Bang, when the first stars shouldn't have even appeared yet. The mission is simple to describe, but deeply unsettling: to find the true point of origin of the universe's first structures. Because if we are already seeing gigantic galaxies just 200 million years after the Big Bang, then it will be necessary to look even further back. 100 million years, 50 million. Webb is trying to pinpoint the exact moment when the impossible ceases to exist, and the normal universe finally begins. But there is a possibility that is making many scientists deeply uncomfortable. What if this limit simply doesn't exist? What if Webb continues looking at increasingly earlier epochs, moments when the cosmos should have been just a hot, uniform plasma, and still continues to find organized structures? In this scenario, it wouldn't be enough to adjust small details of the current theory. There wouldn't be a simple correction to the gravitational models. This would suggest that part of the universe's structure may have come from something predating the Big Bang itself, as if our cosmos had inherited information from an older universe. At this moment, science is experiencing a true battle of interpretations. There are still no definitive answers, only a growing avalanche of data. But this should change soon. In the coming years, the James Webb Space Telescope will not only detect these strange objects, it will begin to analyze their chemical composition with an unprecedented level of detail. We will discover what these structures are really made of. Are they normal galaxies formed by stars? Or are we facing a completely unknown type of cosmic object, exactly as some physicists have begun to suspect? Perhaps they are the so-called dark stars, hypothetical structures powered by dark matter instead of nuclear fusion. Perhaps they are remnants left by an earlier phase of the cosmos. What is becoming increasingly evident is that our narrative about the universe may be incomplete. The cosmos is still far from revealing all its secrets. In a way, the James Webb Telescope has only turned on the light in a dark room, and now we are realizing that almost nothing there seems familiar. And the deeper it looks into space and further into the past, the more we begin to suspect something disconcerting. Perhaps the universe is not just stranger than we imagined. Perhaps it is stranger than we are able to comprehend. So, where does this leave us? For almost 100 years, we believed we had found the great map of the cosmos. We thought we understood how it all began and where it was all headed. But the James Webb Space Telescope has just reminded us of the most important lesson in science. The map is never the territory itself. At this moment, we still don't have final answers. We only have observations. And these observations are showing that the universe continues to defy everything we thought we knew. Whether these objects are impossible galaxies, dark stars, or relics of something from before time itself, one thing is already clear. The story we tell about the cosmos may only be beginning. The universe has just become much more mysterious. And if you want to follow the next discoveries of the James Webb Space Telescope and stay at the forefront of this scientific revolution, don't forget to subscribe to the channel and turn on notifications. Because if physics is really starting to break down, maybe we'll need everyone to rebuild it. Thanks for watching, and never stop looking at the sky.